So we're still in chapter 8, this is part 2. What are the factors we want to consider when we size wire? It's mostly the voltage drop. Usually check on the equipment, what is the maximum size of wire you can use and how long. If you're going to go longer, probably you have to consult the manufacturer and they might recommend different kind of wire. So the voltage drop is a big thing when it comes to installation. Distance, the conductor, that must be and how much voltage you have to feed it. Insulation type, that's very important, especially if the wire is going to be buried or exposed to the element or high temperature. And there's a temperature schedule on the book to tell you what are the limits for all those enclosures. Enclosure is the conduit, or where you're going to put that wire. Is it going to a wall, underground, moisture area, outside, on the ceiling? This is something you have to think about. And safety, what do I mean by safety? Is the wire dangling somewhere? Is it enclosed? Is it just somewhere where it can be tripped on? And probably you'll see that a lot if you go to some houses and look at the setup. Water faucets and drains are next to the wires, and wires are everywhere. It looks like what we call a bird nest, like a cobweb, look, it's all over the place. So that's really bad wiring job. Where do you put the wires and where are they located? And we talked about also the power lines and how the power companies try to trim trees around wires because wire will put randomly in places. And over the time, every company will come put some wires, and eventually you have a big nest of wires interacting with each other, and it's not safe. Voltage drop in conductors, that's again the main thing we have to be worried about when we do wire sizing. Large drop may seriously affect operation, and small drops can be detrimental. And we say these drops, our limits are 10 plus or minus 10%. And why would that affect performance? If you have a compressor requires a lot of voltage, and the capacitor that turn on the motor required to be charged at a certain time. And the more electronically built the equipment, the more sensitive it is to changes. Like these mini splits, they're very, very finicky, require a lot of sensitive operation and a certain amount of voltage. So that's something you have to think about. So when you do the wiring, before you do the installs, measure the end voltage. So you start with 110 the receptacle, you go at the end and see how much voltage drop you have. And maybe you messed up something in the installation, or maybe the wire is not connected properly. So look at the voltage coming into the equipment before you do the connection. Question?
How do you stop voltage drop then?
Huh? You can't stop it, you just have to anticipate it. You don't stop, it's gonna drop. But I want to know how much is it going to drop. So if I measure the receptacle and I have 118, and I run a wire very long, and I go to my equipment and I look, measure the voltage and it's 95. Something's wrong.
How do you stop that?
How do you counteract that? You
Yeah.
have to change the wires. You gotta get different wires. Huh?
What kind of wire do you use?
You have to consult the manufacturer. You'll get the bigger ones because bigger one has less resistance than the smaller one. So you might need to increase the wire size to change the resistance. Otherwise, you might, if you have a huge bundle of wire that's a lot of extra, you might want to cut that off. Get the right voltage. And even though when you measure the voltage at the equipment, you want to make sure you leave some room for the plus and minus because the voltage does fluctuate sometimes. Do you ever notice that during summertime, the entering gets slow? So temperature increases the resistance of the wires, and sometimes the equipment do not function as well. Back in the days of the computer overheats, it's not going to perform, it becomes slower. And a lot of routers, when they're very hot, they do not perform as well. So maximum for branch circuit is 3% plus or minus. What is the branch? It's from the main power to the equipment. Allowable voltage drop for most manufacturers is 10% below the nameplate rating. So what is the nameplate? It's what's printed on the equipment as the voltage required for that. Remember this number for a branch is 3% drop. That's from the main line to the branch. What is considered a branch? You have your main power coming into the primary control. The primary control send power to the igniter, to the transformer, or or the motor, and also to the, what else? Oil valve. That's considered a branch in the main line. So you don't want to deviate more than 10%. Questions? Everybody get that? Get a 3%, that's your report for the branch. And 10% for nameplate. So wire sizing charts, I have someone to look, we can look at it. They're accurate for sizing electrical conductors unless the circuit is extremely long. What is extremely long? That should be the nameplate. They'll tell you from the source this equipment should be not more than 100 yards. And again, ADC is the national code, and that's what we go by, and then we'll go through the book here so you can look at it, or you can have an idea of what we're talking about. Calculating voltage drop in a conductor, the number of feet of wire must be known. This is the, what is E? Voltage equal amperage times resistance. So you can get the resistance and see what is the voltage running through the equipment and deduct that. In most cases, wiring run to heating, cooling, and refrigeration equipment will not exceed 75 feet or 100 feet, which is around 30 meters. So that is something you have to look at. Let me take a look at the schedule in your book. Please do not sell this book after you finish. It's a really valuable book. So this is page 188. AWG, and these are the sizes. This is the biggest wire, 4 zeros, and it keeps going up. And let's look at gauge 14. This is the size of the wire by standards. And look at the ohms. What do you notice for the ohms? Ohms per 1,000 foot at 25 degrees. That is the standards. So would that change if the wire is placed in more than 77 degrees? Yes,
Yeah.
it will be more. So that's when they give you the ohms per temperature. And here we talk about the application and the installation. And remember what we said, there is no absolute insulator.
What?
There is no absolute insulator. Everything will conduct. So depending on how much voltage and how much amperage you run through the wire, you should anticipate what is your insulation. So look at the locations: fluorinated, ethylene, propylene. These are all insulators. There's also paper, and they give you the temperature of operation, location, and the gauge, and our cover. They have covers on them. The reason being, if you have a, did you notice also when we did the wiring, some wires have thicker insulation than the other? Yeah, that depends on how much amperage goes through them. So they want to be safe to each other and safe to touch. If the magnetic field around the wire can go through the insulation, you can measure with a clip-on meter. You can imagine how strong this current is. So it can be strong. You can measure the electromagnetic field, but it also can go through, and you might be able to touch a wire if it has a high voltage in it, and you might feel the voltage. So there is no absolute insulator. And we also saw that this big wire here, it has probably 4,000 volts going through it. 5,000. And we looked at the installation. We've seen this before, right? Look at this wire. And what is the rating here? You should say on it.
What is that again?
That's a power cable for underground. Look at the installation. Real thick, so because we're gonna have 4,000 volts going through it. And that gives you a lot of respect for the transformer, which we were testing yesterday with 10,000 volts. That's a lot of voltage. So that probably will go through a wire and will go through ceramics. Okay, this is very useful here. Let's look at the standards for thermostat. And again, when it comes to code, what is the highest code? NEC. The local code should either be higher or the same. So this is let's look at this as the federal code, federal law, and the state and the town should be different. It has to be higher or meet the requirement. So let's look at the thermostat. Type, operating temperature, and the gauge. So 14 to 10, and you do not require to have a cover. Thermoset and moisture. Yeah, so those thermostat temperatures. And what else? More sizings. Data. Who was asking about the fuse today? Yes. Yeah. You asked me about fuse switches, and this is how we have circuit breakers in residential. We don't have fuses. Because if we were to have a fuse that is 20 amps, it will be as big as this one. And it doesn't make sense for you to break a fuse and you have to go and change the fuse. So we have circuit breakers. Okay, I'll go back to the PowerPoint. Switches. Actually, I'll finish the rest of Friday. It's a good point to stop. So we did